Fieldwork exercise number 3, area determination of polygonal field using tape.
So let me introduce our team. Is led by Rennil Parena, Alsan Enorme, Annielle Joy, Yanzon, and yours truly, Earl, Donde, Loraña.
Fieldwork exercise number 3, area determination of polygonal field using tape. A common problem for a surveyor is the calculation of the surface area of a specific field. The fields are often irregular, which makes direct calculation of their areas difficult. In such case, fields are divided into a number of regular areas, triangles, rectangles, etc., of which the surface can be calculated with simple formulas. All areas are calculated separately, and the sum of these areas gives the total area of the field. Before anyone starts to measure a field, you should first look at the field to see what shape it has. Traditionally, fields seldom have the simple geometrical shapes. The sides are often curved and the shape can be quite complex. In most cases, however, the shape of a field can be approximated by a simple figure. Curved lines can be approximated by straight ones, and the field can be split up into triangles and rectangles, which can all be measured and used to calculate the area of the field. Let's proceed to the objectives. The objective of this fieldwork is to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. Let's move on to the instrument and accessories that we need in order to perform this fieldwork. We have range poles, measuring tape, markers, it can be chalk or marking pits, and lastly, plumb bobs. Now, let's get down to the procedure. Part A, area determination by base and altitude. Step number 1. The instructor assigns the location of 5 points in the field and the students will mark these points with marking pins or chalk. Name these points, which will serve as the corners of the polygon, as A, B, C, D, and E. Step number 2. The chief of party divides the polygon into 3 triangles by taking into consideration that the division should be easily measured. Name the triangles as A1, A2, and A3. Step number 3. Measures the base of the first triangle chosen in the polygon using tape. Step number 4. Then measure the length of the altitude of the first triangle. The determination of the altitude is part of taping operation, which will be discussed by the instructor. Step number 5. Record the length of the base and altitude on table 3.1, area determination by base and altitude. To get the area of the triangle, divide the product of the base and altitude to 2. Step number 6. Repeat steps 3 to 5 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3.
So let's proceed to part B. Area determination by two sides and an included angle. First step. The same field described in part A, area determination by base and altitude, will be used for this method, but change designation on the corners. For example, use F, G, H, I, and J instead of A, B, C, D, and E. Step 2. Divide the polygon into 3 triangles. Step 3. Measure any two sides of the first triangle chosen and record these measurements as sides A and B. Step 4. Determine the included angle between sides A and B and record this on Table 3.2 entitled Area Determination by Two Sides and an Included Angle. To get the area of the triangle, divide the product of a side A and side B and sine of the included angle to 1/2. Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas of Area 1, Area 2, and Area 3.
C. Area determination by Herons formula. Step 1. The same field described in A, area determination by base and altitude, will be used for this method but change the designations on the corners, i.e. use K, L, M, N, and O instead of A, B, C, D, and E, and F, G, H, I, and J. Step 2. Divide the polygon into 3 triangles. Step 3. Measure all the sides of the first triangle chosen and record these measurements as sides A, B, and C on Table 3.3, Area Determination by Herons formula. Step 4. Determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of the semi-perimeter, side A, side B, and side C to equation 4, Herons formula. Step 5. Repeat steps 3 to 4 for the chosen second and third triangles of the polygon. To determine the whole area of the polygon, take the summation of areas A1, A2, and A3.
And this concludes the fieldwork number 3. Thank you for listening.